Hello Algebra 2 students, welcome to part 1 of section 10-5, the law of sines. In this lesson you're going to learn how to find the area of a triangle given the information side angle side, or what we call SAS. Second, you're going to use the law of sines in order to find the side lengths and the angle measures of a triangle. This is what we call solving a triangle. Guys, you know from early grades that area of any triangle is equal to half times base times height. So if you're given the base and if you know the height of the triangle, you can find the area. Today, we're not given the height. The height is unknown, but we're given this side and that side and the measure of the angle between them. This is what we call SAS information, two sides and the angle between them. We have alternative formula to calculate the area of this triangle. The alternative formula says the area of a triangle equals half times the product of the two sides BC times sine the included angle. The question is, how did we get this formula? We get this formula by the help of the trigonometric ratio sine angle A. Sine angle A is equal to, this is the angle we're talking about, guys. Sine angle A is equal to the opposite h over the hypotenuse C. If we do cross multiply, we will get h equals side C times sine angle A. If we take this information and substitute for h in the formula we know, we will get the new formula. Area of any triangle is equal to half the product of any two sides times sine angle A. There are three forms of this formula, the area of the triangle. Since I don't know what are the two sides you will be given, if you given the two sides B and C and the included angle A, use a different form. Area equals half BC sine A, or half AC times sine B, or half AB times sine C. When we label a triangle, we use capital letters to refer to the angles, and we use the same small letters to refer to the opposite side. So opposite to angle capital A is side small a, across angle B side small b, and across angle C side small c. Use this labeling method all the time. Example number 1, it applies the area of triangle formula. Find the area of the triangle and round your answer to the nearest tenth. If you look at the triangle, guys, we given two sides and the included angle, so we can use any form of the area of triangle. So area of triangle is equal to half times any two sides AB times sine angle C. So guys, if you're using the two sides AB, definitely the included angle between them is angle C, and remember to use capital letter for the angle, small letters for the side. Direct substitution, it's half times 5 times 3 times sine, the measure of the given angle is 40. If you compute all of that in your calculator, if you put all of that, it's going to be 4.8 squared meter. Remember guys, area is measured in squared unit and our unit is meter, so the area equals 4.8 squared meter. Since the area of the triangle has three forms and the three forms are equivalent, we can cross out this half with this half with this half. We can divide everything by this half. Also, we can divide the three ratios by ABC. If we divide, guys, I'm trying to prove the law of sines. It is not necessary, but just for your own information. So guys, if you simplify this BC with this BC, and if you simplify this AC with this A and this C, And if you cross out AB with A and B, you will have this law. We call it the law of sines. What is the law of sines? The law of sines is used to solve a triangle, non-right triangle. Guys, in grade 10 you learn how to solve a right triangle, but if you notice, our work today is based on non-right triangle. If you're given a non-right triangle, you can use the law of sines to solve this triangle. And solving a triangle, it means finding all missing side lengths and angle measures. Normally you will be given 3 components and you will be asked to solve the triangle and find the other missing components. Guys, in any triangle there are 6 components, 3 angles and 3 sides. The law of sines, sine of angle A over the opposite side is equal to sine of angle B over the opposite side is equal to sine angle C over the opposite side. I can flip this formula. I can start with the side A over sine angle A, and the formula is still correct, is equal to side B over sine the opposite angle B is equal to side C over sine angle C. Actually, you can use any one of this. Sometimes I use the original one, other times I use the modified one, in order to make the number of steps less than regular. So guys, if you need angle, you use the first one. If you need a side, you use the second one, in order to simplify your problem faster. We're using the law of sines in order to solve a right triangle in 2 cases. The first case, when you given 2 angles and 1 side, 2 angles and 1 side, and the side is either included between the 2 angles, the side is between in ASA, or the side might be not between the 2 angles. So you can use this 3 information, 2 angles and 1 side, with the law of sines in order to solve any non-right triangle. Also, if you given 2 sides and non-included angle, non-included, it means the angle is not between, so you can also apply law of sines. Otherwise, guys, any other different information, you cannot use the law of sines. Law of sines only can be used in case number 1 and case number 2. Case number 1 has 2 scenarios. Sometimes the side is included, other times the side is not included. It doesn't make any difference. In example number 2, I'm going to focus on the first type, when you're given 2 angles and 1 side. Guys, if you look at this triangle, we given angle D and angle F, and we given a side and the side is not between. This is exactly AAS, angle side. I advise my students, since you given 2 angles, make benefit from the triangle sum theorem and find the measure of the third angle E. So start with finding measure of angle E. Remember, guys, we doing what? We solving the triangle. Solve a triangle, it means find the missing information, and currently we're missing 1 angle and 2 sides. So let's start with finding measure of angle E. Since the sum of the 3 angles is 180, so the measure of this angle is 180 minus the sum of 33 plus 28. If you compute that, guys, you will get the measure of angle E. It's gonna be 119 degrees, and it's very good to put your information on the diagram. So this angle is gonna be 119 degrees. Now, guys, we still have 2 unknowns. We need to figure out the side D and the side E. Guys, when you write the law of sines, don't write the 3 ratios, because you need to do cross multiply, and when you do cross multiply, you should have 1 unknown. You cannot have 2 unknowns at the same time. Also, guys, I advise you to use the key ratio. What is the key ratio? The key ratio is the ratio with given information. Guys, if you look at the ratio angle E and the opposite side, 1 information is missing, the side. If you look at D and the opposite side, 1 side is missing and the angle is given. But if you look at angle F and the opposite side, this is what I call the key ratio, because we know the measure of the angle and we know the length of the opposite side. So guys, always use this key ratio to find 1 unknown at a time. So if you want to start with side D, if you want to find, notice, guys, I'm using the second type of the law of sines, the modified form. I started with the side length on the top in order to make the number of steps is less than regular. So d over the opposite angle, sine the opposite angle, sine angle d, is equal to the key ratio is side f, I'm gonna substitute later guys, over sine angle f. Now if you substitute the information you have, d is our unknown, over sine angle d is 33, so over sine 33 is equal to side f is 15 and the opposite angle is 28 over sine 28. Guys, if you want to isolate this d, you need to multiply the two sides by sine 33, because when you multiply this side and that side by sine 33, you can cross out this sine 33 from that side, so you will have d is isolated and is equal to sine 33. Remember, you're multiplying the two sides by sine 33 times the ratio 15 everything over sine 28. If you compute that, if you put all this information in your calculator, you will get the length of side D, and it's going to be 17.4. If you round your answer to the nearest tenth, you will have 17.4. Guys, one more side is missing, side E. Let's personalize our formula. E over sine angle E, the opposite angle, is equal to my key ratio, side F over sine angle F. Substitute this information. E is my unknown. Sine angle E, it's sine 119. I just found this angle at the beginning, is equal to my key ratio 15 over sine 28. 15 over sine 28. Now guys, if you want to isolate this E, you need to multiply both sides by sine 119. So if you do that, you will have E isolated and is equal to sine 119 times the ratio. This ratio is 15 over sine 28. If you compute that, you will have the side E. The side E is going to be 27.9. If you put that on the calculator, you will get 27.9. So guys, now we have found all missing information. We have found two sides and one angle using the law of sines, the case AAS. Two angles and the side is not between. What if the side is between, like this example guys? We given two angles and the side is between. Does it make any difference? Actually, this is ASA, but no difference guys. You should start with finding the third angle. So measure of angle P is equal to 180 minus the sum of 36 plus 39. If you put all of that in the calculator guys, you will have the measure of angle P. It's going to be 105 degrees. 105 degrees. Now guys, I can put this information on my diagram. It's 105. Guys, I can say this ratio is gonna be the key ratio. Remember, the key ratio, it means no unknown. So we're gonna use this key ratio two times. One time to find the unknown Q, other time to find the unknown R. Let's start with writing our law of sines, our personalized law of sines. So guys, I'm gonna start with side Q. Since the side is needed, I'm gonna put the side on the top. So side Q over sine angle Q is equal to, my key ratio is side P over sine angle P. Substitute this information. Side Q is my unknown over sine opposite angles. Sine angle Q is 36. Sine 36. Sine 36 is equal to side P. Side P is given guys, it's 10, and the opposite angle is 105 over sine 105. Now your job is to isolate this Q. You can do cross multiply, or simply you multiply both sides by sine 36. When you multiply both sides by sine 36, you're isolating the Q. So Q gonna be sine 36 times 10 over sine 105 If you put that on the calculator, guys, you will get the side length Q. It's going to be 6.1. Yep, this is 6.1. So we have found the side length Q. And at the beginning, we have found the measure of angle P. So guys, only one more unknown, side R. So this time I'm gonna personalize my formula and start with side R. Side R over sine the opposite angle capital R is equal to my key ratio side P over sine angle P. Use capital letters when you write angles. Guys, now let's substitute this information. R is my unknown. Opposite angle R is 39, so sine 39 is equal to side P, it's 10 over opposite angle sine 105. Do cross multiply to isolate the variable R, or multiply both sides by sine 39. You will get R isolated and is equal to sine 39 times the ratio 10 over 105. Guys, if you put that in the calculator, you will get the side length. It's going to be 6.5. So guys, when you given two angles and one side, either the side is between or not between, you can always use the law of sines. See you in the next part of this section.